Another neat capability in DNS is the ability to forward traffic. A forwarder will receive a DNS request. It will then forward that request for any zones which it is not authoritative. Now, what that means to me, if I have my DNS server and I am in rtsnetworking.com, that means my DNS server is going to have a zone for RTS networking, and in that zone, it's going to have all the records for RTS networking. So they will live locally on that server. That means this DNS server is authoritative for RTS networking. It actually stores the records. Where a forwarder comes in, I have a client that passes a request to my DNS server, and they're trying to get to google.com. That request goes up to the DNS server. The DNS server says, buddy, I can't really help you out with that. I only store records for rtsnetworking.com. I don't know who google.com is. That's where a forwarder comes into play. A forwarder can be another DNS server out on the internet. Actually, a common one is the Google DNS server, which has an IP address of 8.8.8, and they have two of them, and 8.8.4.4. So these are public DNS servers that anyone can use. So what can happen, I can tell this DNS server, when you get a request for any website like Google, Microsoft.com, anything other than RTS networking, you will simply forward that request to this IP address. This machine will assume responsibility for resolving that name. Once it's resolved, it will pass it back to you. So you'll have complete name resolution for all these things on the internet because your DNS just passes it out to another DNS server. The other type of forwarder is a conditional forwarder. So they call one a forwarder, the other they call a conditional forwarder. A conditional forwarder is tied to a specific domain name. What that means, let's say we use the same picture. If I have a partner company, I'm going to say AMF.com. I need to be able to resolve names in AMF.com. This is their DNS server, and I know the IP address of this. I'm going to say it's 3111. I can go to my DNS server here, and I can configure a forwarder that says any request you get for AMF.com will be forwarded to 31.1.1. So now, anything with that domain name gets passed to this server. That is a conditional forwarder. Condition being the domain name. Anything not destined for AMF, not for RTS networking, which is the local zone, that is then going to be sent out to the internet to this 8888 address. So those will be the two types. I just think of it as conditional forwarder means you specify the domain and the IP of the DNS server in that domain. The forwarder here is unknown. If you have no idea what it is, it's unknown traffic, and you specify the IP, all that should be forwarded to somewhere out on the internet. Now, the end result of this is very similar to a stub zone. But some things to keep in mind. Stub zones will primarily be used within the same company because you have to configure both servers. One has to be configured to allow, at a stub zone, to allow records to be transferred. The other has to actually store the records locally on that. If I just need you to resolve names for an application or something like that I may have in my environment that you need as a partner, I don't want to send you any of my DNS records. I don't want to configure my DNS server to support that. So instead, I would just tell you what the IP address is, and you will create your forwarder. If I'm down here in AMF, I don't have to do anything for you to forward traffic to me. You just specify my name and IP address. Now, this does have to be like internet accessible to actually work because you have to be able to connect to this IP address. But as long as that's true, there's no setting in DNS or anything like that that I would ever define. In my experience, this is the most common use of forwarders. it is very likely that your domain controllers are also DNS servers on your local area network or on your LAN. Now, many environments have this type of firewall configuration, where we have a back firewall that separates our LAN from our perimeter network. In our perimeter network, we'll have machines that are internet accessible. Typically, you would have remote access servers fit in here very often, maybe some application servers if they're accessible from the internet, but we have a DNS server here. Now, I label this as DNS only because it's not a domain controller. It only hosts DNS, and that's in my perimeter network. Then we have this front firewall. Increasingly common, this is called an edge firewall, but it just separates my perimeter network from the internet. So on the LAN, I'm basically doubly protected. You'd have to traverse 2 firewalls to connect to the LAN. Then we just have the internet out here. What I don't want to have happen, if I need to resolve names out on the internet, I don't want my domain controller, that's also a DNS server, communicating directly with the internet. We don't want that to happen. That creates just a lot of concerns, because if this connects to something on the internet directly and it's compromised in any way, it stores all your user accounts, your computer accounts. So we want to make sure that does not happen. Easy way to make sure it does not is to have your DNS installed on a server in your perimeter network. Let's say this server's IP address is 172.16.0.11. What I will do now is go configure my forwarder here to say forward any unknown traffic to that address. That easy, I would be completely done. So again, assume the name of my domain is rtsnetworking.com. If this gets any traffic destined for any other domain other than RTS Networking, it's going to pass it through this back firewall to this DNS server. This front firewall only allows DNS traffic from this server to traverse through that edge or front firewall. So I have no concern that my domain controller is ever going to try to resolve anything on the internet directly. This connects to the internet, resolves that traffic from the internet, and then it gets passed back to the DNS server, back to your client, and you have complete name resolution. Now, a common question, how does this DNS server in my perimeter, how does it know how to connect to the internet to get these names resolved? The short answer, it just does. The technical answer, all DNS servers, even non-Microsoft, they come with something called root hints. Root hints are actually a list of the 13 public DNS root servers. Now, when they say it's 13 public DNS root servers, that's very misleading, because they are really massive clusters of servers that are geo-separated that really, I won't say they could never fail, but if they were to fail, the entire internet would fail. So I can only imagine the level of redundancy configured in that. This is just built into all DNS servers. So this DNS server here in my perimeter, it already has this file on it that says out here, we have all these root servers you can connect to assist you in resolving anything on the internet. So with this, I don't have to do anything. It will just automatically connect to the internet, communicate with these root servers, and retrieve that information. So truly, it just works. Now let's take a look at the forwarding and the root hints in the interface.